So here we need to solve the differential equation given by x times dy over dx equals to x plus y with a condition that x is not equals to 0. So let us begin. So we can rewrite this differential equation as dy over dx equals to x plus y over x. Here, this is the function f of x comma y, and this is a homogeneous function. That means if we substitute the value of x with lambda x and y with lambda y, then our function will become, so we have lambda x plus lambda y in the numerator divided by lambda x. And if we take lambda common factor in the numerator, so that will be multiplied to x plus y divided by lambda x. The lambda and lambda goes away from both the numerator and the denominator, leaving us with x plus y over x, which is the original function f of x comma y. So that means when we make a substitution, replacing x with lambda x and y with lambda y, if we get back the original function, then we say that our function f of x comma y is a homogeneous function. Now since the function is homogeneous, so this is an example of a homogeneous differential equation. Now how do we solve this equation? So that means here we can rewrite it as 1 plus y over x. Clearly, this differential equation means that here y is the dependent variable and x is the independent variable. So we'll consider the dependent variable as equals to v times x, where v is a variable. Now we'll take the differentiations of both sides with respect to x. So we have dy over dx. And since we have the product of two functions, v and x, so at the derivative with respect to x can be obtained by using the product rule, which will be v plus x times dv over dx. Now all we have to do is replace dy over dx with this new form, v plus x times dv over dx, into our differential equation. So our differential equation will then transform into v plus x times dv over dx equals to 1 plus we have y over x. So y over x is, this is v is equals to y over x. So we replace y over x with v. Then immediately the v and v gets cancelled out from both sides, and this leaves us with x dv over dx equals to 1. The whole reason for doing this substitution was so that we can convert our differential equation into a new differential equation which can be in a variable separable form, meaning we can rewrite our differential equation as dv equals to dx over x. So this is in the variable separable form. Now we can integrate both sides. The integration of dv, so that will be simply equals to v, and integration of dx over x, or the integration of the function 1 over x is the natural logarithmic function of x, plus the constant of integration c. Now we replace the value v with y over x. So y over x will be equals to natural log of x plus c, or we can do is simply multiply throughout the equation with x, and that leaves us with y equals to x times natural log of x plus x times c. And in this solution, the value of x cannot be equals to 0, and it was already mentioned in the question. That's because the logarithm function is defined for values of x greater than 0. So this is the required solution to a given differential equation.